Hello friends, how are you? Hope you're doing well. So today in this video we're gonna see an interesting project that I've done in Godot game engine. And so let me first of all play this and show you. So here in this project we can draw with mouse on a canvas item. So like this, so I can draw a house like this, and I can also change the color of this line. So let me go to the shader where I have this color property. I can change this color. So let me change this to red color. And if I play line, so the color changes to red, right? So that's an amazing thing. And this is the simplistic way we can make a drawing in the Godot game engine. So like if you see online, there are other plugins where they use the GDScript to draw, but here we are using the shaders for drawing the canvas item. So here I'm drawing on the texture red. Uh, uh, I'm using the texture red for drawing this uh, using a bunch of shaders. So let me explain how the shader is working, and how all the code is working. So it's a simple shader. So if you see, so let me close this. So if you see, there are only I've used two shaders. So one is a buffer shader and the actual drawing shader. So before this, let me explain how this shader is working. So I got this code and idea from here in the Shadertoy, right? So here, if you see, this is a simple code. So here, this is just taking the texture of this buffer and then rendering. And here, if you see, um, it's rendering the dots. So let me first of all draw and show you. Okay, so if I draw, it's actually drawing nice, but but if you draw very fast, so what happens? So if I draw very fast, then it draws like dots. So why? Because so what is happening was every frame. So you can see the frame rate is 165 FPS, right? So every frame is actually drawing a circle, right? So if I move slowly, so it's actually a bunch of circles, right? So you can see it here, like a bunch of circles. But if I draw faster, then due to the frame rate limitation, we are seeing this dots. So what is actually happening? So here you can see the code. Mm, yeah, the distance. So it's taking the distance between the UV as a frag coordinate, and then the mouse position where I click. So if I click here, so it's drawing a circle. So it's actually calculating the distance, and if it is less than 10, so when the radius is less than 10, then it is 1. It is true. So true means it is 1. So if it is, if the radius is greater than 10, then it is black. So this circle within the region is the radius is 10, and outside the region the radius is greater than 10. So that's why only within the circle we see the white color, and the rest of the area is black color, right? So that's how it draws a circle. But when I click in the next frame over here, it draws another circle. But if you see, so according to this code, this should draw only this circle, not this, or the previous one, right? But the previous one is being drawn based on the buffering, self-buffering, something called self-buffering. So here you can see the author has told the shader that remembers the old buffers and lets you paint onto it. So they're actually self-buffering. I mean, referring to the same output. For example, so here they are taking the texture of the I channel 0. The I channel 0 is something about the same buffer. So here they are taking the A buffer. So the same output is being fed into the same loop, and then so this is nothing but the previous rendering. So now these two dots are previous. Now when I click a third one, this is the current circle, and these two are previous one. So it's actually adding, right? So it's adding the previous color plus the current color. So we get a line, right? So when I draw like this, I get a continuous line. So this is how, by the principle of self-buffering, they are drawing this line. And but actually, so if I draw faster, the gap should be filled up, right? So pretty simple. All you have to do is just add a line rendering code. I mean, draw a line between the previous dot and the current dot. This problem can be solved. So here this guy OCD has solved this problem by adding a line segment. So this is the segment. So this code actually draws a line between the dots. So if you see, so it, instead of drawing dots, it actually draws a line. But actually, this is not a. The line is disappearing because the code here they have multiplied by 0.95. Let me remove that. And if I save again, so now I get a line, right? Yeah, so this exact code is what I have taken and written in my buffer shaders. If you see my buffer shader, it's almost the same thing. The distance of the segment formula is same. You can see here, right? So the distance of the formula. So this one, and then what I'm doing, I'm here. Yeah, so here I'm calculating the distance and I'm checking if the distance is less than certain width, then add 1, otherwise it is 0, right? So that's so the line color will be 1 and the rest of the thing will be black. So that's what this buffer is rendering, right? And so this buffer I'm assigning to the So now the question is, so you know how this Shadertoy is working by self-buffering, but how do we do self-buffering in Godot? So the one way I found was using the viewports. So what's viewport? So here, if you go to add child and then just type in viewport, you get something called sub viewport. This sub viewport is what I have used here as buffer viewport and then second viewport. Let me explain why do we need 2 viewports. So this buffer viewport is going to act as the buffer texture, and this is the actual texture. You know, here we are drawing, and this is the buffer texture. This is going to act as a buffer texture, which we're going to feed into our original shader. So this texture is going to have our shader, the drawing board shader you're seeing here, right? And this drawing board shader, so we can select the color and we can assign any main texture. So here I have assigned just a white texture. So instead of that, we can assign any paper like texture. So then I have the buffer texture. So here, if you see, this buffer texture is nothing but this buffer viewport, this buffer viewport, right? So that's the buffer texture, and what it does is just so here, if you see in my code, it just wherever the buffer is white, so I'm taking the R channel. So wherever the buffer is 1, this color will be rendered. Otherwise, the main color, the base color, the main color is nothing but the white texture. The white texture will be rendered, right? So this color is nothing but this selected red color, right? So that's how this code is working. But yeah, so now if you see, so how this buffer color, so this buffer texture is coming from this buffer viewport, and so your viewport basically renders whatever is the child, right? So I've given the color rect as a child, and this color rect holds the buffer, this drawing buffer shader. So you can see here, this material is having this custom shader with the drawing buffer shader applied. And yeah, so here comes the actual code, right? So you know how this is. Yeah, so here I'm passing the mouse position and the previous mouse position. So yeah, so we need you already know the concept, right? So how the line is being drawn. So so based on the previous mouse position and the current mouse position, we have to draw a line. So instead of appearing as dots, we are making it as a continuous line. So yeah, so and we need to pass this mouse position and previous mouse position. So how I'm passing? By using this script attached to this texture, right? So if I open the script, and you can see this is a simple script. I'm just taking the buffer material and then assigning this mouse position and previous mouse position uniforms, and the mouse position is the current mouse position that is on the the main viewport, and then the previous mouse position is the mouse position on the previous frame, right? So that's how the script is working. And so why do we need a second viewport, right? So if you see here in the color textures, we need a buffer texture as a uniform. So this buffer texture has to come from another viewport, right? So this viewport is having a texture red. This texture red will be assigned this buffer. So if you see, this main texture is just being applied the buffer viewport as the main texture. So this is the way we can actually buffer the current rendering viewport, right? And also make sure the second viewport is always staying at the top of the buffer viewport. Otherwise, the rendering order will be changed, right? So let me once again play it and show you, right? So yeah, I can draw anything. I can draw a mountain and sun. Now you may ask why everything is red. Why can't we change the color? Yeah, that you can do. That you can. So this is a simplistic form of drawing. Then you can create a script where I can change the color dynamically. So here in the shader, every time I need to every time I need to change this color and then replace. So instead of that, you can write your own GDScript logic here that which will dynamically change this color uniform from the script. Then you can draw it over here. You can so you can draw it over here. So that's all, guys. So hope you understand. If you have any doubts, comment me. I'll answer to you. And if you like the video, please like this video and also subscribe to the channel. So thank you for watching.